Welcome to clickmyproject.com. Let's discuss on the paper optimizing a tone curve for background compatible high dynamic range image and video compression. In this paper, we address the problem of finding an optimal tone curve for such background compatible encoding scheme. To compute the tone curve, we propose a method that minimizes the difference in the video quality between the original and the reconstructed HDR video. This difference results in quality loss and is due to tone mapping, encoding, decoding, and inverse tone mapping the original video. Minimizing this difference would reduce the size of HDR residual signal in the enhancement layer. We also achieve the primary goal of tone mapping, which is produce an LDR image with a visual response as similar as possible to the original HDR image. Although the initial assumptions used in our approach pose a different optimization problem, we demonstrate that for a typical compression distortion, there exists a closed form solution that approaches the optimum. Let's discuss on the DFT. Considering the DFT, first consider the original HDR frame, then tone map it. When you are tone mapping it, it will be converted to a tone mapped LDR frame. This frame is encoded and you will be getting a LDR output stream, which is in the form of zeros and 1 bits. These are subjected to a decoder. In the decoder, the result is a distorted LDR frame. So to get the original HDR quality, you have to this distorted LDR frame have to be subjected to inverse tone mapping. So in the inverse tone mapping procedure, the lost contents are retrieved here and the reconstructed HDR frame is got here. Again, you have to sum this original HDR frame with the reconstructed HDR frame and subject it to encoding, and you will be getting a residual stream. In order to know the depth about the original process, there are two models. One is closed form solution and another statistical model. In the closed form solution, we are subjecting the original HDR frame and the tone mapped frame is given to the closed form solution, and as a result what we get is subjected to a statistical model. This statistical model is capable of reducing the distortions. So on the previous procedure, what is given in encoding and decoding is applied here too, and as a result of inverse tone mapping, you will be evaluating the error. Let's evaluate the algorithm. Select main hdr.m file and click run file. This is a guide designed for evaluating our algorithms. You have to select one of the files. All these files will have a number of frames. For example, when we are selecting a search file, you will be getting various frames taken under various lighting conditions. You have to subject this to a closed form model, which will provide you a closed form output with a minimized distortion error. This may take some time, where the encoder and decoder process have to be carried on, and this is the closed form output. It has given an output with milder distortions. In order to correct this, you have to subject this result to a statistical model, which creates a number of maps to elevate the distortions present in the HDR image. Then this is the statistical model output. This is the luminescence value of the HDR image, and this is a graph representing it. And the second graph is about LDR values after tone mapping. You will be getting the LDR image as such. And in the figure 3, this is a tone curve. You have to take a optimized curve. This is for closed form solution and this is for statistical solution. This tone curve should have a S-shaped bend here, then means the distortion will be reduced. This curve is plotted for LDR values and the x-axis consists of the intensity values. And in figure 4, we will be representing a low pass activity map, which is one of the process involved in statistical model. And in figure 5, subband activity map. So all the informations are separated in band-wise elements. And in figure 6, you will be getting an aggregate activity map, and this is subjected to get the gain map. And in the final figure, you will be getting a subband gain map. In organizing all these gain maps, you will be getting a statistical model with very minimized distortion, which could be noted in the mean square error. This is a table that displays each and every output, and this is for church frames, which is giving a minimized reconstructed error. That is, input MSE is 4.3750 with an epsilon value, and here it is a negative. So we can understand that we have got a minimized MSE, and this is a comparison for all the 4 frames. This is the input MSE and reconstructed MSE, in which every frame has eliminated its distortions. Finally, we are able to understand that these distortions provide a very good analysis on the MSE. Our proposed tone mapping methods can directly improve the compression efficiently by using the bit depth scalable video coding. The proposed methods are designed to produce a better reconstructed HDR representation. A direct consequence of this design objective is a reduction in size of the higher bit depth, which contains the difference between the reconstructed HDR image and the original one. Thus, our method can lower the total bit rate of the bit depth scalable coding. Although the primary goal of tone mapping algorithm is to optimize the visual quality of the displaced LDR image, we instead design a tone mapping operator that optimizes the compression performance in the backward compatible encoding scheme. Thank you.